Welcome viewers to another episode on calculus. Now in this video we are going to look at how we can differentiate sum and difference of different functions. So let's set and then look at what we have for today. Now we want to find the derivative of the following function, or find the y dx of the following function. So the first function we have here is y is equal to x to the power 4 plus 3x to the power 3 minus 5x to the power 2 minus 2x minus 12, or plus 12. So this function, or this question, is made up of different functions which are adding or subtracting from each other. So we are going to look at how we can differentiate functions of this nature. So because we have only one dependent variable, what is y, on the left side, and independent variable x on the right side, we differentiate y with respect to x. So that gives us dy dx. So as we did in our previous lesson, to differentiate a function which has an exponent to the independent variable, we multiply the exponent by the coefficient of the independent variable. So the variable x has a coefficient of 1. So we multiply the 4, which is the exponent, by the coefficient here. So the coefficient is 1. So that's going to be 1 multiplying 4. Now bring your x. Now the exponent of this x is going to reduce by 1. So that is going to be 4 minus 1. Now the next function is 3x to the power 3. So the exponent will multiply the coefficients of the x, which is 3. So plus the coefficients 3 multiplying the exponents, which is 3. Good. Now we bring your x. This time around, the exponent of the x will reduce by 1. So that's going to be 3 minus 1. The next function is negative 5x to the power 2. So the exponent will now multiply the coefficients of x, what is negative 5. So negative 5 multiplying 2, and you bring your x. Now the exponent of this is going to reduce by 1, so that is 2 minus 1. Now we have another function, what is 2x. The exponent of this x is 1, but we don't write it 1, it is to the power 1. But you have to know that there's 1 there. It means every number in its natural state is to the power 1. So what we are going to do is that the exponent 1 here, what is invisible, we are going to multiply that 1 by the coefficients of the x. So we have 2 multiplying the invisible 1, and bring your x. Because there's 1 here, the exponent is still going to reduce by 1, so that is going to be 1 minus 1. Now the derivative of a constant function is always 0, so you can bring your 0 alongside. So we go ahead to write out dy dx. Dy dx is going to, now 1 times 4 gives us 4. X to the power 4 minus 1 gives us x to the power 3. 3 times 3 gives us 9. You write your x. Now 3 minus 1 gives us 2. Now negative 5 times 2 gives us negative 10. You bring your x. Now 2 minus 1 is 1. But as I told you, when it is 1, we don't write it. But know that there's 1 there. Alright. Now negative 2 minus 1 gives us negative 2. Now x minus 1, x to the power 1 minus 1 gives us x to the power 0. And remember that any number to the power 0 is always 1. So if this is 1, whenever we multiply 1 by 2, or 1 times negative 2 is still negative 2. So there's no need to bring x again. Alright. Now plus 0. This 0 is insignificant, so it wouldn't change anything, so we ignore it. So that's the derivative of the function x to the power 4 plus 3x cubed minus 5x squared plus or minus 2x plus 12. That is the derivative. Now let's look at another function here, what is y equals to 1 over x cubed minus 2x squared plus 3. Now it will be more appropriate to change every fraction you want to differentiate into its index form, so that it becomes so simple for you. So y is equal to this 1 over x cubed can also be written as x to the power negative 3. This is from our indices. So minus 2x squared plus 3. Good. Now we are going to differentiate each of the function. So differential of y is going to give us dy dx. So once again, the coefficients of this x is 1. So write it here. Now the exponent is going to multiply that coefficients. What is 1? So the exponent is negative 3. So 1 is going to multiply negative 3. Now you bring your x. Negative 3 exponent is going to reduce by 1. So negative 3 minus 1. Now minus. Now the exponents in this function is 2. So this 2 is going to multiply by the coefficients of this x, what is negative 2. So negative 2 multiplying the 2. Then bring your x. The exponent is 2, which is reduced by 1. Now the differential of 3 is 0. It's a constant function. So whenever you differentiate a constant function, as we said earlier on, it is always 0. So dy dx. Now 1 times negative 3, that's negative 3. Your x is here. Now negative 3 minus 1 gives us negative 4. Negative 2 times 2 gives us negative 4. X. 2 minus 1 is supposed to be 1. It's when it is 1, we don't write it. So everybody will know that there was 1 here. So you need to get that mathematical eye. Now plus 0. 0 is insignificant. It wouldn't add or subtract anything from it. So we call it additive identity. So there's no need to bring the 0. So that's the derivative of the function 1 over x cubed minus 2x squared plus 3. Good. Now, better still, you can rewrite negative 3 over 4 or negative 3x to the power negative 4 in this way. Negative 3 over x to the power 4. Then minus 4x. So you can write it this way. Now let's come to the last question on this slide. We have a function y is equal to square root of x plus square root of x cubed. Now this function, we call it radical functions because they are under square root sign. Now when it is in radical form, it will be very difficult for you to differentiate. So it is better we write them in their fractional index form. So from indices, whenever you have let's say square root of a, this is the same as a to the power half. Okay, so let's use this idea to write the rational index for these radical functions. So y is equal to, now square root of x the same as x to the power half plus, now square root of x to the power 3 also give us x to the power 3 all to the power half as the fractional index form. So let's keep on writing. So y is equal to x to the power half plus, now we are going to multiply this. So from indices, let's quickly, from this is whenever you have a to the power m exponents n, is going to be a to the power m multiplying the n. So we have two different exponents here. So what do you do? That the exponent will multiply. So that is the exact feature of this work. So let's apply this on what we have here. So that's going to be x to the power. So 3 times half will give us 3 on 2. Good. So we are now set to differentiate. So we are differentiating y with respect to x. So that gives us the y, the x, which will give us. Now the exponent here will multiply the coefficients here, and the coefficients here you have to know it that there's 1 here. So 1 multiplying the exponent half, you bring your x, then half minus 1 plus. Now once again the coefficients for this function x is 1. We bring it and multiply by the exponent, which is 3 on 2. Now x will be 3 on 2 also minus 1. Therefore dy dx is going to be, now 1 times half will give us half. Now you bring your x here, so half minus 1 give you negative half, and then plus 1 times 3 over 2 is 3 on 2. You bring your x here. Now you have the exponent of this function to be 3 over 2 minus 1. So just pick your calculator and find 3 on 2 minus 1, and that will give us half. So that will give us 1 on 2. So that is the derivative of the radical functions over here. But you can go ahead to show your power in indices. So dy dx. Now this half x to the power negative half can also be written as 1 over 2 to the power x to the power half plus 3x to the power half over 2. And you can go ahead to write the x to the power half as square root of x, and that is also correct answer. Please, once again, don't forget to subscribe, comment, and you share to your friends. Thank you very much.